Hello, and welcome to this section on immutable data and on pure functions. Some wise man once said that you can never step into the same river twice. Each time you step into the river, you are a different person, and the river is a different river. Let's adapt this philosophical question to our study of Scala. Can you ever cross the same river twice? Well, it turns out that in Scala, you actually can. And this has to do with the nature of data, with the immutability of data in Scala, and with a related concept, that of pure functions. Immutable data is not a concept that's unique to Scala. It's present in Java, for instance, where a lot of data items, member variables, are marked as final. Strings in Java are immutable as well. You can't really modify a string. Scala does differ, however, in that immutability is the norm rather than the exception. In Scala, when you declare a data item, you preface it with the word val or the word var. Entities or data items that are prefaced by the word val are immutable. These cannot change once they come into existence. It is possible for data items to be variable or mutable, but these again are used extremely sparingly. The idiom of Scala is such that the use of for loops is rather infrequent. Instead, operations are supplied to collections, and those operations are then carried out using methods of those collections. This means that the use of collections such as lists is extremely important in Scala, and by default, those collections are immutable as well. In reality, it is possible to create either mutable or immutable versions of all of the common collections, but the default is the immutable version, and the combination of immutable data and immutable collections leads to pure functions and also easily distributable code. Let's get to what pure functions are and why they help with making code concurrent, safe, and distributable. But first, let's really quickly look at a few simple data items declared in Scala. A really simple constant pi that has been declared to be immutable via the use of the prefix val. Notice how we do not specify the type. Scala uses something known as type inference. This allows it to infer what type a particular storage unit or data item is. What would happen if we sought to modify the value of an immutable data item? Well, predictably, Scala would throw an error. And that error is on screen now. You can see that there is a reassignment to val that has been flagged because we have attempted to redefine the value pi so that it is set to 3.1415 rather than merely to 3.14. The idea is a pretty simple one, but as we shall see, it's powerful. Immutable data items just cannot be modified once they've been initialized. It is, of course, possible to create data items that can be modified. Use the prefix or the keyword var, var rather than val. Use mutable data only when you have a really good sound reason for doing so. For instance, if you are going to use this variable as the counter in a while loop, not a very commonly used construct in Scala. The common collections in Scala are immutable. When you instantiate a list or a map or a set, what you're really instantiating are the classes collection.immutable.list, map, and set, respectively. Any modifications that you make to these immutable collections will result in the creation of new collections which have the modified values contained within. The concept of immutable data items is rather closely tied to that of pure functions. A pure function is one that does not have any side effects. A function is said to have side effects if it interacts with the outside world or modifies state. If it prints to screen, writes to file, any of these operations constitute side effects. In contrast, functions which do not have side effects return a value, and this return value is the only value that is changed by running this function. If you were to call a pure function twice with the exact same inputs, you would get the exact same outputs, and the state of the world, the state of the program would remain exactly the same. Pure functions, when called or invoked on immutable data, are often easy to reorder. Anytime there is no relationship between the return values of such function calls, they can be reordered by a compiler. And extending that, pure function calls to immutable collections are also often easy to parallelize. Immutable data is thread safe, pure function calls are free of side effects, and so it's quite safe and actually quite easy for a compiler to decompose this pure function call on an immutable collection into a bunch of parallel calls on subsets of that collection. Here on screen is exactly such a pure function that is being invoked on an immutable collection. We have a list containing the names of all of the weekdays. We use the map operation on the list and we supply a function object which tests whether each element in the list is equal to Monday. Notice the underscore that is known as a placeholder, and we'll have more to say about the placeholder syntax in sections to come.